Welcome to the Explainer. Today, you've got a front row seat to a pretty high-stakes technical interview for a senior Java developer role.
So, could you? We're about to break down the expert-level answers to some of the toughest questions on multithreading and concurrency. Let's really dig in and see what it takes to knock it out of the park.
Okay, first things first, the building blocks of concurrency. The interview always starts with the absolute fundamentals. Get these wrong and, well, you're already on the back foot. Here it is, a classic opening question. It seems simple, right? But the interviewer is looking for more than just a definition. They want a clear distinction and, crucially, to see if you understand the best practices. And that is just a perfect, concise answer. The developer doesn't just define them, they immediately state the best practice and explain the why. That right there, that shows real-world experience. What's really interesting here, if you look at the table, is that concept of coupling. Decoupling the task, the what you want to do, from the execution, the how you run it, that is a fundamental principle of good software design. Interviewers love to see that you get that. Okay, so the interviewer now probes a little deeper, testing the developer's understanding of how the Java virtual machine actually manages these threads behind the scenes.
And this just brilliantly illustrates the journey of every single thread. Knowing these states isn't just for passing a test. It is absolutely crucial when you're trying to debug really complex concurrency issues like deadlocks or weird performance bottlenecks.
Now the interview shifts from the what to the why. It's focusing on the absolute central problem of concurrency. How do you safely manage data when multiple threads are trying to access it all at the same time?
This one tests the developer's knowledge of Java's most fundamental locking mechanism. This is a real cornerstone of concurrency control. You have to know this.
And again, just a fantastic answer. It hits all the keywords: mutual exclusion, the object's monitor lock, and the whole point of it all, preventing those nasty race conditions.
This is a notoriously tricky one. It's almost specifically designed to catch people out. They sound similar, but their behavior with locks is completely different. Let's see how they handle it.
So, the whole thing boils down to that first line. Wait releases the lock. That's essential for coordination because it lets other threads jump in and do their thing. Sleep, on the other hand, just pauses, selfishly holding on to any locks it has. Big difference. The interviewer is now shifting gears, moving into modern concurrency utilities. This is a great way to test if the developer's knowledge is up to date with all the powerful tools we have available now. This is a super practical question. It's all about performance and resource management. Creating new threads on the fly is a huge no-no in high-performance applications.
So in short, creating threads is expensive. Reusing a pool of existing threads is really the modern standard for building high-performance, scalable apps. It's all about working smarter, not harder.
Oh, a great follow-up. The interviewer is guiding the conversation from those simple fire-and-forget tasks to the more complex asynchronous jobs that actually produce a value we need to use later. The key difference here is pretty clear. Callable returns a value, and it's wrapped in this special object called a future. It can also throw checked exceptions, which just makes your error handling way more robust and explicit.
Now that's an advanced question. The interviewer is really pushing here, trying to see if the developer knows how to build truly non-blocking, reactive systems and avoid all the performance problems you get from just sitting around and waiting for results.
And there it is, complete future fit. Honestly, this is a game changer. It lets you chain asynchronous operations together, handle results as soon as they become available, and manage errors, all without ever blocking your main threads. This is how you build incredibly efficient and responsive systems today. Okay, we've reached the final boss level of the interview now. These questions are about the most dangerous pitfalls and the most advanced tools in the entire world of concurrency. This is a non-negotiable topic for any senior dev. Getting this wrong in a real-world system can literally freeze an entire application, bringing everything to a grinding halt. And the candidate correctly identifies the 4 so-called Kaufman conditions. For a deadlock to actually happen, all 4 of these things have to be true at the exact same time. So the key to preventing it is to design your system to break at least one of them. And notice the most effective strategy up there? Consistent lock ordering.
It's a simple discipline that, if you follow it religiously, can completely eliminate the risk of deadlocks in your code. It's all about having rules and sticking to them. From the basics of the thread lifecycle all the way to the advanced hazards of a deadlock, mastering concurrency is really about building software that's not just correct, but resilient and performant under pressure. So the real question is, how would your answers stack up?